In this chapter, we will talk about how clocking works in DDM. Understanding clocking will help us design and set up our Dante networks successfully. As a disclaimer, the language we are using in the technology community is evolving to be more inclusive. You will notice that we try to use inclusive language like leader, follower, as opposed to master, slave as much as possible. However, some places may not have changed due to legacy content and/or applications or standards that have not changed yet. If you remember our Dante Certification Level 2 course, we talked in detail about clocking and how it works in a typical unmanaged Dante network. Clocking is sometimes confusing to understand, but it doesn't have to be. Clocking is critical to establishing synchronized audio and video communication. Dante uses PTP for clock sync, and the process is quite seamless. As we have discussed before, Dante devices on a network discover each other and establish clocking automatically using what is called the best master clock algorithm, or BMCA. The BMCA will choose a clock leader based on a multitude of parameters. There are also options to use an external clock or set a particular device as a preferred leader. Now that we have brushed up on some of the basics, let's look at how clocking works in a DDM environment. The first and most important feature of clocking in DDM is that each domain has its own clock setup. Each domain has its own leader to which the devices are synced to. Now, this separation occurs even if the devices are on the same subnet but in different domains. This does give you the ability to break up flat networks into multiple clocking domains, all of which are extremely helpful for security and management. It's important to highlight that when you enroll devices into a domain, the clock election process is redone and will get a new leader elected based on the BMCA, as we talked about before. You can set the clock functions either on Dante Controller or Dante Domain Manager, depending on certain scenarios. In this example, you see this device is a PTP preferred master because that option is checked. You can also see that it is sending multicast PTP v1 to devices within its own domain. The best part, however, about a DDM deployment is that DDM is capable of auto-configuring the domain clocking, so you don't have to manually change things. Knowledge of it, however, is always helpful. DDM enrolled devices have three main clocking levels. Since its beginning in 2006, Dante has been using PTP v1 within a subnet. This is still in use today because there are a lot of devices on the market that primarily support this. As you probably know, PTP v2 as a standard was released in 2008. With the ever-growing network landscape, Dante has constantly evolved to ensure compatibility with the standards. This is why Dante also supports PTP v2. We can use unicast PTP v2 for clocking devices across subnets. A DDM-based Dante environment also supports multicast PTP v2. These are extremely useful in a wide range of deployments. We can use this with external GPS clocks, which we will go into more detail later. Multicast PTP v2 is also how clocking is established in AES67 or ST2110 interoperability modes. Let's take a look at an example of single subnet domains. In this convention center, we have created domains where a group of devices are managed by a single DSP in the meeting room areas and a dedicated auditorium space. We therefore have three domains: North meeting rooms, South meeting rooms, and an auditorium. Once the devices are allocated to each domain, there will be a clock election process. In this case, we'll see that the DSPs in the North and South meeting room domains and a mixer in the auditorium has been chosen as PTP v1 clock leaders. Now let's take a look at Dante Controller and Dante Domain Manager. Obviously, because it's a DDM-based Dante system, we'd need to log into the Dante Controller. But other than that information, we see is not different than how things would have been in an unmanaged Dante network. In this example, the DSP is clearly elevated to the role of the primary v1 or PTP v1 multicast leader. It provides clock sync to all the devices in the subnet within the domain. Going to the DDM interface also gives us information on the clock status. The settings of the domain show that it has a single subnet clocking type with an indication to the device that is the clock leader for the domain. Clicking on the Advanced Settings button reveals more information on the domain clocking. The DSP device is seen to have a crown in its status column, indicating that it is the grandmaster or leader for the domain. You will also see a clock followed by a dot with forked arrows, showing that it's provided multicast clocking to the domain. When the devices are in clock sync, we will see green dots next to each device in the status column. Always a good sign when we see green. Okay, so what happens when we create domains that span multiple subnets? As we can imagine, this setup is slightly more complex, but nothing to worry. DDM simplifies all of this for you. In this example, we have two routed networks, 10.102.21.0/24 and 10.102.22.0/24 subnets. Once we have configured the networks to be able to communicate with each other, clocking will be established. Since all the devices in the two different subnets are part of a single domain, what happens next is that one of the devices is selected as the grand leader for the domain. Devices that are in the subnet will establish sync by following a device that is selected as the PTPv1 multicast leader. This can all be done automatically, or you can configure it manually. A different device will also function as the boundary clock for the devices in the second subnet. Each network segment or subnet will have its own boundary clock. Let's break this down further. Once the ground leader has been established, it then sends the clock information to the boundary clock in the other subnet over unicast. While multicast in a single subnet environment is an extremely efficient way of communicating, unicast is the way to go when traversing networks. So basically, the boundary clock receives unicast PTP from the domain leader and establishes itself as the multicast leader for the devices within the subnet. Just know that the ground leader will function as multicast leader in its own subnet, in addition to being the boundary clock. And how does this look in Dante Controller? If we go to the clock status tab, we'll see that in this example, one device has been elected to be the ground leader for the whole domain. A quick message under the domain status column can tell you which device is the domain leader. Now you'll also see, like we explained before, that the same device is the PTPv1 multicast leader for the subnet. All the other devices will be listed as followers. The second subnet shows a device that is a follower in the domain status column. And that device is the boundary clock receiving unicast PTP and also the PTPv1 multicast leader for the subnet. This information is also reflected in Dante Domain Manager under the advanced settings for each domain. Domain clocking gives you a visual status of the clocking situation in the domain. The device that has the crown next to it is the ground leader for the domain. The next image is a clock. When the single arrow points away from the clock, it means that this device is the unicast leader. The unicast follower will have the single-headed arrow pointed towards the clock. The clock followed by a forked arrow indicates that the device is the multicast leader for the subnet. When you enroll a device from a different subnet into a domain, it's not going to automatically configure itself like the way that single subnets do. This is intentional because we want the DDM admin to take control of the process. DDM will issue alerts that a unicast-capable device is available but enabled. You'll also see alerts that indicates that there are multiple ground leader devices. The configuration process for multi-subnet domains involves defining boundary clocks like we have previously discussed. Once those are established, then clocking information begins to flow over unicast between network segments. This ensures that even if devices are segregated or segmented, the audio flows because all the devices are clocked to a single source. When we navigate to the DDM, we basically have two options. Our first choice is to click on Auto Configure and let the DDM establish the clocking. This is a fairly straightforward process considering the DDM uses the BMCA, which we described earlier. Once clicked on, DDM will elect a domain or unicast clock leader, a boundary clock in each subnet, and a backup boundary clock that takes on the role of leader if the original boundary clock were to go offline. All that with the click of a button. Now, there are definitely times when you'll need to manually configure clocking. These depend on your architecture, system clocking complexity, or that you just want to be more granular with the controls. You can do all that as the DDM administrator. Let's review this in the following slides. Clicking on Advanced Settings opens up the clock settings for the domains. The first set of options are audio clocking parameters. We'll go over that in detail later in this lesson. Right below that, you'll see domain clocking. This is a list of all the devices enrolled in the domain separated by the subnets they are a part of. In order to designate devices as boundary clocks, whether they are the unicast leaders or followers, we need to click the slider buttons of the respective devices on the unicast clocking. There is a clock collection process here as well, which determines the leader and follower, which can be customized if needed. In our current example, the mixer from the 192.168.3.0 subnet is the domain leader because it has the crown next to it in the status column. Well, actually it's both, the unicast and multicast leader. You'll notice that the unicast clocking on the intercom device has also been enabled. This is to function as a backup in the event we lose the mixer. It's always recommended that a backup unicast clocking device be designated in each subnet. Same thing in the 192.168.2.0 subnet. You'll see that there are two devices with unicast clocking enabled, the demo speaker and the DSP. Based on the status icons, the DSP is currently the boundary clock, which means it receives unicast clocking from the mixer as a follower, and is the multicast leader for the subnet. When setting up clocking, it's good to remember that unicast clocking is limited to 40 devices per clocking domain. While this may seem like a large number of Dante devices on a network, can quickly add up. This is also important to consider when you are designing your network architecture. Here's an important lesson. Not all Dante devices can become a boundary clock. Devices that are running a firmware version older than 4.0 are incapable of becoming a boundary clock. This doesn't mean they can't be part of DDM-based Dante environment. Legacy devices can still be associated with a domain. While Audinate is constantly trying to enhance our features and functionality through updates, our amazing manufacturer partners still decide what firmware they want their devices operating at. If there is an update available, it's always recommended to update your devices to the latest software update made available by your manufacturer. Currently, a lot of our popular software offerings like DVS and VIA, and also solutions part of Dante Application Library or DAL, are incapable of becoming a boundary clock. However, our Dante embedded platform is capable of becoming one. Check out this link that you can also find in your resources for our current information on clock-capable devices and platforms. Most of our hardware Dante implementations are capable of becoming a boundary clock. When designing networks with boundary clocks in mind, it is always better to implement devices with more powerful chipsets, usually with higher processing and channel counts, like Brooklyn 2 or Broadway. An easy way to figure out what chipset a particular device has is to look under Device View in Dante Controller. Alternatively, reach out to your manufacturer or the Audinate website if you're trying to figure this out. Now, we do have some exceptions. Legacy Ultimo devices which are listed as Ultimo or Ultimo 4 cannot become boundary clocks. These are typically older devices that have 2 to 4 channels. Ultimo X devices are the newer chipsets that can become boundary clock, but usually only can provide clock information to 40 devices. Having more than that may lead to some of the devices going out of sync and therefore losing audio. Just so you are not confused, Ultimo X devices will be listed as Ultimo X or Ultimo X4 when you look for chipset information. Let's talk real quick about shared audio groups. We touched on some of these topics already in our lesson on shared audio groups. One of the best ways to reinforce things we learn is to rewatch topics that have already been covered. So check out our section on shared audio groups to refresh your memory. We already know that creating a shared audio group involving multiple domains unifies the clock leader for all the domains. Take a look at Dante Controller and navigate to a domain that has devices that are part of a shared audio group. If the device that's functioning as the leader clock between the domains is outside of the domain, it will show up as an unknown device. But don't worry, navigating over it will show you the MAC address of the devices. In this case, the leader is within the subnet, which is why all the devices are showing up as PTPv1 multicast followers. Logging into DDM is the best way to figure out the clocking details. Going into advanced settings will give you an understanding of what the clocking looks like. Right at the top, it will say the name of the domain along with the number of additional domains being clocked in the combined clocking setup, along with the name of the shared audio group. So in our current example, the auditorium domain is being clocked with one other domain in a shared audio group named shared. Hopefully, that didn't seem too complicated, which is why we also have a demo that we can look at. In our first case, we are going to look at an example of clocking in a single subnet environment. Let's start off by creating a domain called Business Center Bathroom. If we go to Devices, we see that there are several devices in the Unmanaged section from different subnets. Just so everyone can follow along easily, we have most of the devices named based on their intended domain. Hence, there are devices with Business Center Bathroom in their names. These devices are in the 10.102.21.0/24 subnet. Let's go ahead and enroll them all in the domain that we just created. If you don't remember, go to the section on enrolling devices to refresh the different options you have when enrolling devices into domains. Go to the Business Center Bathroom domain under Domains, and you'll see that the clocking type is listed as single subnet as explained. It also mentions the devices functioning as the ground leader. We have some additional configuration options under the advanced settings. A quick look at domain clocking will show you the device that has assumed the role of the ground leader. Since it's in a single subnet, the clocking is being propagated as PTPv1 multicast. If there is a particular device that you would like to have assume this role, you can always use the Customize option and toggle the preferred master option, or from Dante Controller where you can check the box that says Preferred Leader. Now let's demonstrate multi-subnet clocking by creating a domain that spans multiple subnets. In our current example, we created a domain named Public Announcement. A look in our Devices section revealed that we have three different subnets: the 10.102.20.0/24, the 10.102.21.0/24, and the 10.102.22.0/24. Again, for easy of following along, we have the devices already named with PA in their names, indicating that they belong to the Public Announcement domain. There are devices from the .21 and .22 subnets which can be enrolled in the domain. We'll see that now the clocking type appears as multi-subnet, with a warning under settings that says there are multiple 2 grandmaster devices. So the first and simple option to resolve this is by just clicking the Auto Configure button. DDM uses the process that we explained before to set up a multi-subnet clocking structure. The other option is to do it manually. Let's take a look at how we can do that. If we go to Advanced Settings and look under Domain Clocking, we'll see that there are actually 2 devices that have been elected as grand leaders. One for the .21 subnet and the other for the .22 subnet. The first step is to force a device to be preferred leader like we did in the single subnet example. We do this for 1 device in each subnet. Now remember, our setup is not complete. We have just allocated devices that will remain in the multicast leader. So the next step is to enable unicast clocking on both devices. The clock collection process takes place and determines the device in the .21 subnet is a domain clock leader. It is therefore sending unicast clocking across the subnet to the device in the .22 subnet. The device selection process that we showed here is unique to this example. You will need to use the information learned in this chapter and others to determine what is the best device clocking structure that you need. DDM supports this at a very granular level. It is highly recommended that you select another unicast clocking device in each subnet in order to have a backup. Just remember that those devices need to have at least the 4.0 Dante firmware version, okay? Well, our next demo is on shared audio groups. We have covered a lot of this information, we know, but the focus on this demo is how clocking works on shared audio groups. Let's quickly create a shared audio group between the business center and the campus domains. As soon as we do that, the clocking structure reconfigures. We see there is a warning that says there are 2 ground leader devices. So we are going to resolve this manually. Entering advanced settings shows us that there are now 2 different subnets spanning 4 domains. What do you think needs to happen next? Well, if you answered enable unicast clocking so that both subnets can be clocked to a single leader, you got it right. Once enabled, in the .21 subnet, the clock DEP bathrooms is acting as the boundary clock. It receives clock information from the primary leader as a unicast follower and sends out multicast PTP for its own subnet. In the .22 subnet, we see that the clock DEP theory is acting as the primary leader, sending the unicast clock to the other subnet and also acting as the multicast leader for its own subnet. And there are 2 other devices as backup for the unicast clocking in both subnets. Now, if we open our Dante controller and log into the DDM using our credentials, we'll see in the clock status tab for the business center bathroom, the primary leader appears as unknown device because it is a device that is in another domain. A look at Dante controller shows only the domain to which the primary leader belongs. This will show the device name under primary leader clock. All the other domains will only show unknown device. This is easily explained. We may have created a shared audio group which necessitates having a combined clocking setup, but the devices are still separated by the domains to which they belong to. There are also some custom clocking features in Dante Domain Manager that we can enable when we want to sync our devices in Dante mode to an external clock. So this section does not go into AS67 or ST2110 interoperability. Here in this example, I have my Dante domain and have all my Dante devices enrolled in that domain. Outside of that domain, there is another device that is functioning as a GPS clock. That device is outputting PTPv2 as an external ground leader clock. So one of the devices in our domain will need to be a PTPv2 follower and therefore elected as the PTPv1 leader to sync all the devices that are not capable of syncing to PTPv2. So what is the difference between PTPv1 versus PTPv2? Basically, IEEE 1588 defines the standard for high accuracy synchronization of clocks over Ethernet. Well, PTPv2, which was introduced in 2008, introduces many features that PTPv1 from 2002 previously didn't have. It added flexibility, accuracy, and scalability to the standard, introducing unicast messaging and flexible sync message rates for timestamp communication, adding boundary clock and transparent clock functionality, enabling 2 devices to synchronize accurately when separated by intermediate network devices. And so are all features of PTPv2. By utilizing network switches capable of becoming boundary clocks, we can create intricate PTP-aware networks. That is why the use of PTPv2 to sync to external clocks is highly recommended. A DDM-based network allows you to control the PTPv2 settings and adjust them as needed. This is not possible in PTPv1, where the elections are automatic. Let's see all this is done. Under the advanced settings in a domain, you will see a section on audio clocking parameters. Under mode, you have the option to keep it at default or enable the AS67 or ST2110 interoperability modes. For our current example, we can leave it at default. The next set of options are under PTP configuration. The default supports PTPv1, but there is a custom PTPv1 plus PTPv2 mode. Enabling that gives you the ability to configure parameters that help define the clocking in a PTPv2 enabled network. So if you select that option, the first step is to define the domain number. When we split the devices into domains, What we are doing is changing the PTP domain number. When we set it to a particular number, it needs to match up with the external clock source. Once this is done, it will ignore the clock messages that do not have the appropriate domain number as configured in the DDM. To reiterate, the information entered here must match that configured in the external or GPS clock source. The priority 1 value is basically a number that determines which devices will be selected as clock leader. It is one of several factors that are used in the clock leader election process. Remember, the lower the number, the higher the priority. For example, we've set up the priority at 1 to 8. If there was another device on the network that had, say, 1 to 9 or 130, those devices would be less likely than the devices that have 1 to 8 as their priority. What happens if there is a GPS clock on a network or a better clock source? You would probably want to set it up to a lower number than 1 to 8 in order for it to have a higher priority. It is also worth noting that GPS clocks will likely win a clock leader election when the priorities are matched. Like mentioned before, there are several hierarchical parameters that are accounted for when by virtue of being GPS clocks. There are some other election parameters than the ones we mentioned before in the PTPv2 that are clock classes. If your clock is a GPS clock, that's high up in the election process. So typically, it won't matter what you select here. The GPS clocks will win unless you really mess with the priority values. In this example we've got here, you can see there is an external ground leader on this domain. And you can also see that one of your Dante devices has been elected to sync with that external ground leader and act as a boundary clock. Remember, in order to do this, we need Dante devices that have firmware version 4.2 and above. It basically receives PTPv2 clocking as a follower to the external source and provides PTPv1 multicast to the devices within the subnet. Now, you are probably asking yourself, what are GPS clocks? And where do I use them? Well, GPS clocks are based on atomic clock technology. But again, what does that mean? Okay, there are satellites in the GPS or Global Position System network that have highly accurate atomic clocks built in. Each of these are synchronized on the ground to a single master clock. When the GPS clock units power up, they are synchronized to these satellites and therefore provide a very accurate clock source that can be spread across globally. There are many manufacturers who provide these units, and here are some of examples. As you can see, they come in different sizes. This leads us now to where do we use them? If you remember our level 3 class, we mentioned that one of the primary uses of GPS-based clocks in DDM-enabled Dante systems is when there is a need to traverse large distances. There are two terms that we use interchangeably in AV network conversations, and that is latency and jitter. Now, these are very expansive topics, unfortunately outside of the focus of our conversation today. But I will attempt to define them real quick. Latency is the delay between a packet traveling from a source to a destination. And jitter, on the other hand, represents the variation in set latency. As we attempt to cross large distances over switches, routers, and data centers, we will have higher latency. This is expected, but latency over forms of transmission also has significant variation leading to high network jitter. Jitter is experienced even in local networks, but it's not significant enough to be a concern. Now, generally, the higher latency for media packets can be tolerated. Dante gives you the flexibility to adjust your latency window so that packets come within the range. But when it comes to clock synchronization, the system is far less forgiving. The clock has to figure out what to do with this variation in clock arrival times. So in order to solve this, the common solution is to use GPS clocks. The GPS clocks are synchronized to satellite sources, providing a synced and localized clock source for devices in what we call clock zones. Let's take a look at an example. So in this example, we have two different subnets that are geographically in two different cities. The 10.102.10.0 for Boston and the 10.102.20.0 for New York. Both subnets belong to the same Dante domain, but we have created two separate clocking zones, each with its own ground leader that is a PTPv2 follower to the GPS clock leader in its network. The setup is pretty self-explanatory from that point on. We talked briefly about clocking zones, but now let's dig deeper to understand the rules around them. The first requirement is that each clocking zone must be its own subnet. In our previous example, we say that Boston and New York were the two clocking zones, and each had their own subnet. We saw the use of GPS clocked external leaders. Clocking zones need that their external ground leaders must be synced to a source, whether it be GPS or anything else. This also requires Dante devices with firmware version 4.2 and higher to be able to receive PTPv2. Remember that this functionality needs to be considered during the phase because these are differences in these features based on our Ordinates chipset implementation. The popular Ultimo X in our AVIOS, for example, does not support PTPv2 in a DDM environment. Remember to use our website resources to keep yourself updated. Now, it's time for a demo. Okay, so let's take a look at how we use GPS clocking with Dante Domain Manager. First, I have a domain named Broadcast Studios and it's a multi-subnet domain. I've got devices in my first subnet, 10.102.21.0/24, and some others in a second subnet, 10.102.22.0/24. Our clocking is already set up, and I've got this device acting as the ground leader clock of the domain. If we take a look in Dante Controller, you can see that we have the same device here as the primary leader clock, and everything looks great. Now it's time to enable the GPS clock sources. On my network, which in this case is a Time Machine's GPS server, has been set to a clock domain on 1. Also note, its MAC address ending in 3D is 7. So the Time Machine server is on my first subnet with an IP address of 10.102.21.120. The first thing we have to do in DDM is go to the advanced settings. You can see right now we are using the default Dante setup clocking scheme, and again, it's multi-subnet. So it's a combination of PTPv2 unicast and PTPv1 multicast. You can see we've got our domain leader clock here, unicast, acting also as the PTPv1 multicast leader for that subnet. And then down here is the boundary clock also acting as a multicast leader for its respective subnet. Now, in order to use an external PTPv2 clock, we must change the PTP config from default to custom B1 plus B2, and also the PTPv2 domain number to match that with the GPS clock. I click Save Changes, and then what happens is the devices are going to resync. If you noticed, now it appears we've got an external ground leader. In other words, we are syncing to an external network clock. If we go back to Dante Controller, you'll see that things have changed there as well. On the Clock Status tab, you'll see that the primary leader clock of the domain is now an unknown device with an asterisk. If we cursor over that, it gives the MAC address of the device, which, if you remember, is the same one we saw from the Time Machine's GPS clock, ending in 3D E7. The other thing that you need to pay attention to is it's using PTPv2 multicast. So this device from here and this device over here are following that external clock because they are running 4.2 Dante firmware. We also have a domain leader which is using unicast to sync devices in the second subnet. Then those devices here in the second subnet are following that PTPv1 multicast leader. Well, everything in the broadcast studio now is effectively chasing that external leader clock. Other applications where GPS clocks are used is when we want to send Dante over distance. For example, some studios could be in the same building but in different subnets, or in different floors, etc. Or if you wanted to cover greater distances, it could be across the state or country. If you need to synchronize your audio, we'll need to create clocking zones that we previously discussed. Now, for this example, let's say the devices in the first subnet are located in Portland. First, we click on the Assign Zone button, then type in Portland. Then click in the Create New Zone option, and finally OK. You'll notice in the newly created Portland zone, it's already using that external GPS clock, so that's all synced up. Next, we plug in another GPS clock in the second subnet. Once this is done, we need to create the zone for this subnet, and let's say this is in Los Angeles. We click in the Create New Zone, and then OK. Again, both GPS clocks are set to domain 1, but are on different subnets. So now we've got the devices in Los Angeles syncing to this GPS clock, and the devices in Portland synced to its own GPS clock. Now, if we move to Dante Controller, you'll see that in the top, the primary leader clocks are unknown devices. And again, if I hover over it, it will give me the MAC address of both GPS time servers. In the PTPv2 multicast column, we've got these two devices with 4.2 firmware following the GPS clock in Portland, and this following the GPS clock in Los Angeles. Now, in a DDM environment, we do also have access to higher latency values. If we double-click the device to open the device view, and then click the device config tab, we will see that now we have up to 40 milliseconds, where before it used to be up to 5 milliseconds. DDM truly extends the functionality of your Dante network. Whether it be about scaling, and you need to add multiple devices on a wide range of subnets, or if it's about pushing the boundaries of previous physical limitations and being able to send audio over long distances, or if it's having a unified clocking structure. DDM does it all. Okay, so we know this was a large topic, and I'm sure you'll have some questions. So please reach out to us via email on sales@audinate.com or check out our website. Also, it may be a good idea to rewatch this video at some point. We hope you enjoyed, and now on to the next one.